Hey guys, today's video is about proximity measures for binary data. I'll only talk about binary attributes in this video, and you can find the others in my channel. To recap, proximity measures calculate the similarity or dissimilarity between two objects, and binary attributes have only two states, which is typically denoted as 0 and 1. There are two types of binary data. If state 1 is more important than state 0, we call the data asymmetric binary. By convention, we use 1 to represent the important state, so you won't see the situation where state 0 is more important than state 1. On the other hand, if state 1 and state 0 are of equal importance, we call the data symmetric binary. The first step to calculate the dissimilarity of binary data is to build a contingency table. Contingency table is used to present the frequency counts for categorical data. To illustrate, Q is the number of attributes object I and object J are both 1. R is the number of times object I is 1, but object J is 0. And I'm sure you can infer the meaning of S and T based on this. In fact, Q and T represents matches between two objects, and R and S represents mismatches where the states of object I and J are distinct. After understanding contingency table, we can now look at the dissimilarity for symmetric binary data. The formula is R plus S divided by Q plus R plus S plus T, which is basically total number of attributes. Actually, the numerator, R plus S, is a number of mismatches, where one of the objects is 1 and another is 0. Therefore, this formula represents the dissimilarity between object I and J. Then, we can look at asymmetric binary data. The formula is R plus S divided by Q plus R plus S. The difference is in the denominator where T is removed. T presents a match where both object I and J are 0. However, we remove T since 0 is not important in asymmetric binary data. After erasing T, the dissimilarity actually increases since the number in denominator becomes smaller. Therefore, we won't underestimate the dissimilarity between two objects. I also want to introduce a measure called Jacquard coefficient. Jacquard coefficient is another name for asymmetric binary similarity. That is, Jacquard coefficient is 1 minus the dissimilarity for asymmetric binary data. Let's look at this example. Ray and Jenny are object I and J. They both did 5 tests, and the result is either positive or negative. Before applying the dissimilarity formula, we first create a 2x2 contingency table. For convenience, we assign positive to 1, negative to 0, but it doesn't necessarily mean 1 is more important than 0. Now, we can fill in the numbers in the contingency table. There is only one test where both Ray and Jenny are 1, which is test 3, so we put 1 in the top left corner. Again, there is only one test where Ray is 0 but Jenny is 1, which is test 5, so we put 1 in the bottom left cell. Then, there are 2 tests where Ray is 1 but Jenny is 0, which are test 1 and 4, so we put 2 in the top right cell. Last, test 2 is the only case where both Ray and Jenny are 0, so we put 1 in the bottom right cell. We now have a complete contingency table, so we can ignore the original data. Do you remember there are 2 types of binary data, symmetric and asymmetric? Just for reference, I put the formulas on, but you don't need to memorize what Q, R, S, and T mean in the contingency table. What you really need to do is to get your head around the definition of dissimilarity. Dissimilarity measures how different two objects are, and mismatches represent the difference. Therefore, the numerator is always the total number of times where a row index is different from the column index. For instance, When row index is 0 but column index is 1, we call it a mismatch. For the denominator, it's intuitive for symmetric data that you just count the total number of columns. However, for asymmetric attributes, you deliberately ignore the times when both objects are 0, because, by definition, 0 is less important in asymmetric binary data. So, if we see these attributes as symmetric binary, the dissimilarity between Ray and Jenny is 1 plus 2 divided by the total counts, which is 1 plus 2 plus 1 plus 1, and we get the answer of 3/5. We then try to solve the dissimilarity for asymmetric binary data. The dissimilarity between Ray and Jenny is 1 plus 2 divided by 1 plus 2 plus 1, where we remove the 0 matrix. So the answer is 3/4. The Jacob coefficient is the asymmetric similarity. It's just 1 minus this asymmetric dissimilarity 3/4. So the Jacob coefficient is 1/4. So, we've gone through the dissimilarity measures for binary attributes. I want to emphasize that you don't need to memorize the formulas. Just make sure you understand the definition and meaning of symmetric and asymmetric binary data. Thank you for watching my video and see you next time.